Testing 1, 2, 3. Hi, Mr. Matters again. Let's continue our hexadecimal binary to hex discussion. Okay, let's say I have a number. Remember our table. You got to go back and look at your table. Remember, the key is A is 10. 0 through 9 is the same as hexadecimal and decimal, and A is 10. Uh, A is 10, B is 11, C is 12, D is 13, E is 14, F is 15. Okay, pop question. F is what? 15 in binary. Nope, 15 in F in hex is 15 in decimal and 1111 in, guess what? Binary. Okay, here's a question. I got this up here. 1 0 0 1 and then 1 1 1 1 and then 1 1 0 1. I want to take this and convert it into something in base 16. How do I do that? Well, do I move from left to right or right to left? Well, really, you want to move from right to left, although in this case I got a perfect number. I got 12 of them. But I move from right to left and group them into chunks of 3. Well, chunks of 4, right? That's all you got to do, just chunk of 4. And then I take this. The next step is to give them each one of these columns in their decimal equivalent, base 12 down here. So I got to turn 1101, which is 1, 2, 4, 8, which is 8, 9, 10, 11, 12, 13, right, into its decimal value. That base, this over here means base 16. That's ultimately what I'm getting to. But in the process of doing that, I've got to take each one of these and get them into their binary, I'm sorry, their decimal equivalent in the chunk of 4. Chunks of 4, chunks of 4. Now, if I was converting binary to decimal, I would start all over. This would be 16 right here. But I don't. I do 1, 2, 4, 8. And then 1, 2, 4, and you guess what? 8. So you're only going to have 1, 2, 4, 8 at the top. 1, 2, 4, 8, 1, 2, 4, 8, 1, 2, 8, 4, 8. When you're converting from some 2 to base 16. Now this is 8, 9, 10, 11, 12, 8, 9, 10, 11, 12, 13, 14, 15, right? Everybody understand that this is 15? And then this is 8 plus 1 is 9. So what's my response here? Answer is 9. And you know that F is 15 by the table. You need to look at binary to decimal less than 1. And then, this is, let me see. I can't remember this myself. A, B, C, D. This is A, B, C, D. 10, 11, 12, 13. A, B, C, D. Right. This should be D. I have to count on my fingers. So the answer is 9FD base 16. Okay? Isn't that cool? All right. Look at that for a minute. And let's turn around and do another one. I'm going to wipe the screen here. Nope, don't want to do that. Don't want to save it. So let's take 1, 2, 3, 4, 1, 0, 0, 1. And let's see what that happens to be. Turn it from base 2. I want to go x, meaning some value, in base 16. Another way to turn this around is to say x base 16 equals to this right here, base 2. Just flip these two left and right. I do it this way just because you're converting, it's like you're converting from to, okay, from left to what's on the right. So this, of course, is, you got to turn it into your take them, group them in chunks of 4. You've got your binary number 12 here. That means I want to convert it to decimal. That's all that means. And then what am I going to do? Each of these, by the way, now have their own little binary equivalent. Okay? Sorry. Had a little hiccup there. And so what I want to do is I want to turn this, remember 1, 0, 0, 1 is, guess what? 9, which is 1, 2, 4, 8. I'm doing this with my left hand, and I'm right-handed, by the way, because I use my mouse on my left hand. 1, 2, 4, 8. And this is going to be 15, right? 15 is F. 0 through 9 are the same, so F9. You can see all the bits. See, the bits are going to be the same. Doesn't matter how you flip them around. All right. A while ago, I had 1, 0, 0, 1, and then 1, 1, 1, 1, and then some other value. And that was 9F something else, right? So let's just continue this. So this is the F9. Base 16 is the value. Okay? That means base 16. Clean the slate. Let's do this. What if you have a value like this? 1, 0, 1, 1, 0, 1. Oh no. You don't have an even number of bits. In other words, they're not grouped into chunks of 4 perfectly. So what do? That's why you move from right to left. So 1, 2, 4, 8. There's the first chunk. Base 12 is where we're going to turn them into next. Well, then I'll pad this over here with leading zeros to kind of help you. 1, 2, 4, 8. Well, this is easy. Drop the 2 down. There's only the 2 that's marked, right? And then 8, 9, 8, 9, 10, 11, 12, 13. And that's the decimal value. 2. Now, A, B, C, D, 10, 11, 12, 13 is D. 2D base 16. There you go. Okay? Okay, I'm going to pause that for a minute. Everybody see that? Just take a look at that. I'm going to clear that. And now I'm going to bring up a calculator. Show you something else. Bring up the calculator and you click View Scientific. You'll see a bunch of stuff here. Decimal, octal, base 8. We don't deal with except in Unix a little bit. Bin for binary, H for hex. Well, let's take and click on binary. And we did 1, 2, 3, 4, 1, 0, 0, 1 a while ago. Let's turn it into hex. Boom, F9. You see that? You need to understand the mechanics behind here, but this also shows you how you can do this to double check your work. Let's take and see what the decimal equivalent is. 249. Okay. Why? Because you take this and you convert it into all these bits in here into its decimal. So it'd be 1, 2, 4, 8, 16, 32, 64, 128, keep on going. Okay? We'll close that. And this is, let's see. One last question I want to leave you. What is, if 15 is A, I'm sorry, 15 is F, 15 base 10 is F in base 16, then what is 16 in base 10 equivalent to in base 16? Well, let's think on that. All right. If you email me, I'll guide you. Okay. Thank you very much. Copyright Todd Motors, 2007.